So thanks everyone for joining. We have Chris Crone on the line from very sunny California, I believe, is that?
Yeah, I'm up in the mountains in California. This is actually
Breathing
not a
the
virtual,
fresh free air.
I was
Excellent.
going to say it's not a virtual background; it's real.
I know. You got to keep moving to show that it is definitely real background behind. Yeah. Right. So if you don't know Chris, which I'll be surprised if you know Db2, he now works for Broadcom, but he did work for IBM for 30 years in the Db2 DOS development area. And he's worked extensively with customers, new development projects, prioritizing requirements, and advising how best to use Db2 to achieve their goals. And I know a few sessions he's come into NatWest Bank to show how complex bits of Db2 can really be. And we really value those sessions. So I hope you guys are going to enjoy this session. So I'll shut up now and hand over to Chris to show us all about Db2 12 SQL changes along the function levels between 501 and 508.
I only got to 507. Didn't do 508. Just came out. But actually, thank you very much. I should say maybe I have another soft spot in my heart for the GSE UK, because it was last year in Milton Keynes that Greg Lotko gave me an offer to work at Broadcom, and I guess you could say it was an offer I couldn't refuse. So here I am now with Broadcom, and happy to be with you virtually. I would have much rather been with you in the UK because I'd be much closer to a pint this evening, but here we are. So, all right. So there we go. All right, we're gonna go over the Db2 12 features, but before then, we're gonna start about with a little bit of information about version 11. Because there's some building blocks in version 11 that that without the version 11 background doesn't necessarily make sense. So, and then we'll cover the Db2 12 SQL, and we'll cover SQLPL, the changes in SQLPL, and then we'll cover all the function levels. So everything will be mixed in the function levels. So, all right. So let's go through the initial building blocks that I think are important to understand. The first thing to understand here is, just checking my time here, is the array data type in Db2.11. And the array data type in Db2.11 was in SQLPL only. So you could declare something in SQLPL, you could pass it from an SQLPL routine to another one, manipulate them in SQLPL, but they were only in SQLPL. And that made their usage kind of interesting if you were an SQLPL developer, but there was a big chunk of capability missing. The one other place that you could use SQL or the array data type in version 11 was the type 4 driver for JDBC. If you had the type 4 driver for JDBC, you could either call a stored procedure and pass an array in, or return an array parameter out of a stored procedure. And that's because the LUW guys had added this array data type quite some time ago, and they had added that support. So it was really just turning it on in the driver to allow that to happen. And it is type 4 only because the type 2 driver is, even though it may seem like it's running 64-bit, actually passes data below the bar. And so passing an array below the bar could be problematic. So the type 2 driver is not enabled for this. So there's a couple different types of arrays, the ordinary array and the associative array. Ordinary arrays are really very simple. They're just, you declare something, and in this case, I've got a size of 1,000 entries. Associative arrays are bounded by memory. So as long as you got memory, you can create really large ones. And they are, they're either have an integer or a varchar as an index to them, and we'll talk a little bit more about those things. But essentially, you use as an example, you can use a name as an index into the item. So, all right. In this particular case, you've got an array that you've declared. It's called my ordinary array, and you're going to get some data into it. And how do you get data into an array? You typically use the array ag function. You can actually set a value. In particular, you could say array, my ordinary array, square bracket, index 1, square bracket equal a value, but that's kind of tedious to go and set 42 values in this case. So the easiest way to get some data in there is to use the array ag function. Both of these statements, either a set statement or a select statement, are equivalent. So this is just filling up this array. And I guess I should say, I hate talking virtually because I can't see how any of you are doing. And I don't know if you can unmute yourself, you can ask a question. Otherwise, I'll just continue to talk and pretend that I'm sitting alone here on my deck. All right, so I've got some data in an array, and I want to get the data out of the array. So in this particular case, I wanted to get the median salary out of the array. And so you're going to use the onNest function to essentially walk through the array, feed the median function just like you would as a table. So onNest is essentially a table function if you think about it that way. And you can see that the average or the median salary in this case is 49,545. And if you think about that, that's a pretty decent salary because this employee table was created in the early 80s. So those people apparently were making some pretty good money back in the 80s. All right, so in this particular case, I'm going to just walk you through an example with an ordinary array in an SQL PL procedure. So I'm going to return some values. The first one's going to be an integer, and it's called the out total, and the other one is the total greater than 1. And so what I'm going to do is I'm going to declare an ordinary array, and I'm going to set it with the array ag function. So I'm going to process the sales table, fill it up, and then I'm going to do two different selects, essentially. The first one, I'm going to set the total value. So I'm going to do a sum of the sales from onNest. And then the second one, the total greater than 1, I'm going to do a sum of the sales where sales is not equal to 1. And I guess that's probably not greater than 1, but it's in this particular case, since there was no negative values in sales, it was greater than 1. And as you can see, there's just two different values there. So essentially, arrays are like tables, and you can do anything you want with them. Okay. If you want to position in a associative array, you use the array first, last, next, prior, delete, or array trim to do various operations. That just kind of, especially for an associative array where it's unbounded, you can add and delete members from the array, and it basically just removes it, like it removes an item out of a linked list. You can think of it that way. Okay, the other key item in version 11 of DB2 was global variables. And global variables in version 11 were only for simple types. There were no lobs, and there were no global variables of arrays. And essentially, you can think of them as created global temp tables similarly to those, in the sense that they're not actually global, they're thread local. I don't create the names of these things. These are SQL standard names, but they're thread local. And a couple of interesting things about them is that they're non-transactional. So you can set a global variable and you can issue a rollback, and the value is still set. So that's kind of, you can think of that as a feature. If you're doing something like CICS processing and you're using entry threads, so protected threads, the value of a global variable will remain constant across usage. So in other words, you could set it in one transaction and you can come back in another transaction. And as long as that thread is being reused, there's residual data there. So you kind of maybe want to think about that. You don't want to put something that's, GDPR information as an example or something like that in there, because obviously that could be a security concern. The other thing is, because as an example, kicks, recycles threads every 1,000 usages by default in the background, you can't really depend on them being there. So they're not like a place that you can actually store a value and be guaranteed that on the next transaction it'll be there for that transaction, because you might get a new thread as an example. They are controlled via grant and revoke. So not only do you create a global variable, but you give access to somebody to set it or to reference it. And so that's kind of an interesting thing, because you could potentially create a global variable and only allow certain packages, as an example, to have access to it. And we'll talk a little bit more about that later on, because Db2's got a new global variable in the latest function level that you may want to control access to, as an example. And they're essentially, like I said, you can write them or create them, instantiate them with a lot of different statements. So select into, set, in-out parameters on a Sql procedure, as an example. And they can be referenced pretty much anywhere where an expression can be specified. There's a few restrictions, but they're pretty versatile. The two main things that were in version 11 that we're missing is, like I said, arrays of global variables and large objects. So there's no large object global variables in version 11. And here's just a real simple example of a global variable. So I create a global variable called current TS, and I set it using a set statement. So cur TS is equal to a value. And then I say select current timestamp as now, comma, cur underscore TS as previously from sysIBM system1. And you can see that previously is a few seconds earlier. And I ran this statement when I created these slides back in February, pre-COVID, man, I think about that. All right, so version 12. Let's start off with SQL changes in version 12, and we'll tie back to these version 11 things in a little bit. So the first one is pagination, and in this particular case, Db2 added some additional capability to pagination. In version 10, there was this new NI access path that was multiple index access on the same index, and you could do data-dependent pagination for equal and not equal values. And now with version 12, you can support range predicates, basically, so you can do greater than or less than or equal, etc. Again, I wrote this slide in February, not knowing that I was going to be presenting it a couple days after the election, but I guess it's apropos, perhaps. So prior to version 12, you would say, where last name equals Trump and first name is greater than Donald, or last name is greater than Trump. And now with the version 12 syntax, you can write that much more simply. And you can say, well, last name, comma, first name is greater than Trump, comma, Donald. And in this particular case, it may seem odd, but I believe the answer is Joe Biden. Sorry, bad joke, but it looks like Joe's going to win here. He's probably on course to at least hit 270. So,
just at that point, Chris, I think I've got a question coming in from Aurora.
Okay,
about
I can't see
performance
anybody,
pagination. It's just, I'll see if I can unmute her so that she can speak. Aurora,
Hiya, can you hear me? Yeah.
Oh, yes.
Hi.
Hello.
Hi, Chris.
Good
First
morning.
of all, yes, I haven't slept in 4 days, and I certainly hope that it will be Joe Biden. But anyway, I'm like, I haven't got any not any fingernails, any fingertips anymore. I haven't been biting them so hard. But anyway, pagination. We have some developers that have decided to use pagination, and we have found incredible performance hits using it, or they have found. They really stress our systems, and the return times are increasing exponentially after the first 1,000 rows. So is there anything that we can do to work around that? Because basically they're finding that pagination is killing their queries.
Interesting. You know, so I don't know without looking at access paths, et cetera, but this is designed to use, so this is called data dependent pagination. And it's designed to use this, this single index, but it's doing multiple index access on a single index, right? Assuming that you have an index that can solve this particular query, right? So that's the first thing is you want to go and look at the explain output and see if you have this NI access path.
Okay.
But if you are getting that access path, typically you know, again, back to version 10, you're getting pretty good performance in there, because what's happening is that we're positioning on the data using the index to get there, right? And like I said, we might do multiple probes to establish position. But once you get that, you know, it's very efficient to get, say, a screen full of data as an example, which I assume is what you're doing.
Frankly, I have no idea. They're doing it. I'm the person that gets that call saying, we have a 5 million row table. We are doing pagination, data-dependent pagination, and our first query took 0.3. You know, the first tranche of the query took 0.3 seconds, and now we're up to 15 minutes.
It doesn't sound like you've got the right access path. So that's the first thing I would check, is to make sure that the query's been written and you've got an index to support this query, this predicate. Okay.
Yeah. Okay.
Right.
I'll point this out, because it was just we know about this new SQL because it's killing us, or killing our developers.
Well, that's obviously not the intent of producing the capability.
Okay. Thanks very much, and yeah, may the only good man win, by the way.
Yeah, I guess, you know, prior to this, the greater than Donald Trump would have been Melania, Ivanka, but apparently Joe Biden's in there now. All right. So numeric pagination is a little bit different, and it basically is you know, designed to support different screen sizes. So, you know, you can have a phone, you can have an iPad, you can have various other sorts of technologies that need a certain amount of data. And the screen size is obviously, you know, on an iPhone, the screen is 20 rows, and on an iPad, it's 30, and on a desktop, it's 40 or something. And, you know, you can easily do that with numeric pagination. Prior to version 12, you could have done it with scrollable cursors, although scrollable cursors aren't widely used. You could use it with row set positioning, so you can actually step through something using a row set. Or you could do what a lot of people did, which is they fetch, as an example, 20 rows and discard the first 10. And obviously that's not very efficient. So you can use rows, the rows sizes and offset together to kind of walk through. And what an offset's basically going to do is it's going to say, you know, I want to go and give me the first 10 rows. And then I want to go get the next 10 rows. So I'm going to offset by 10. So I'm going to read the first 10 rows. And what will happen is Db2 will actually qualify those rows, but not return them. And so that type of pagination is very expensive, because you actually have Db2 qualifying the rows under the covers and not returning them. You might say, well, wasn't there a fetch n rows clause before? And there was, but n was a constant. Okay, so that meant that you had to code, you know, fetch 10 rows, fetch 20 rows, and fetch 30 rows as an example, as different SQL statements. And now you can use either a host variable or parameter marker there. So this example just shows you, you know, you can say fetch first 5 rows previously, and now you can use a parameter marker to do that. And there also is some other syntax here, which is a limit or offset. That is a SQL standard syntax, but the Db2, I'll call it preferred syntax, is using the fetch first X rows and the offset clause instead of limit, but it does support either. Okay, another new feature that was added was the ability to add fetch first M rows with a number on a search delete. And the use case here is really the ability to walk through data and delete it in some sort of data maintenance type operation. So customers, previously had to do something like code a COBOL application or something that went through and did a delete where current of, as an example, and then did a commit every 50 rows or something. Here you can do this with a search delete, and you could imagine doing this like in a script, something like delete 5,000 rows, commit, delete 5,000 rows, commit, delete 5,000 rows, commit. Or if you go to this iDoug blog that Meg Bernal and I wrote probably 2 years ago now, 3 years ago, they'll show you the SQL procedure that's on the next page and how to do that with an autonomous SQL procedure. So in this example, you've got an autonomous SQL procedure. You're going to feed it in an SQL statement and the number of rows that you want to delete. And we're going to build up a statement, a delete statement, and we're going to say fetch first some number of rows, and we're going to loop in this procedure and doing an execute immediate over and over again, basically doing say delete of 5,000 records, and then commit, and then a delete of 5,000 records, and then commit, as an example. So fairly simple application, but it allows you to do a data maintenance operation. And not, as an example, deal with lock escalation, or you could have adverse reactions to the coupling facility because you're flooding the coupling facility with locks. By issuing a commit every so often, as you're doing this, you're essentially purging those locks out of the coupling facility. So nice example there. A couple things to notice. If you're doing pagination with a fetch statement, Db2 is going to assume that if you don't specify an optimized for n rows, they're going to assume that the fetch size is 25. So they're kind of guessing that that for a fetch you're trying to get a screen full of data, and an average number of rows for a screen full of data would be 25. If you're doing a delete, they're going to guess that you're doing 10,000 records. So they're kind of the optimizer is going to say, well, I don't really know how many records this person's going to get with this delete statement, but 10,000 is a reasonable, size to issue a commit. So just to let you know what the optimizer is thinking in that space. There was some concern about performance in this space because you could do something like this original query with a fetch first 10 rows, but you ended up with a union all and materializing millions of records into a work file. So what the optimizer does in this particular case is they push down the fetch clause, and in this case they also pushed in the order by. So what's going on here is that they're gonna fetch 20 records into the union all and then return 10 out of that work file. So it gives it a little bit better performance than obviously materializing a whole ton of records. All right, merge. So merge, you might say, well, isn't merge from version 9? And the answer is yes. But that merge was really, if you Google something called upsert, that was really upsert. And what it would do is if it qualified a record, it would update it. And if the record wasn't there, it would insert it. And that meant a lot of use cases. But the use case that it didn't meet that was really missing in this space was the ability to merge two tables together. I remember back in version 9, we hadn't even gone GA in Db2 version 9 before customers started asking, well, where's the ability to have a table reference there? So the extended merge in version 12 has a lot of capability. It's also equivalent to the ANSI standard version of merge, which has a little bit different capability. For the biggest one is that you're not allowed to reference a row twice, and I'll show you an example of that. So how do you know which one you're using? If you issue the not atomic continue on SQL exception or a value statement, you're using upsert. And I remember back in the day, when they added the not atomic continue on SQL exception, thinking, wow, that's a lot of words. And it still is. Sometimes when you deal with the standards people, they come up with crazy syntax. So if you're not using either of those clauses, you're using the new enhanced or extended merge. This example here is just showing you the original upsert, and what's going on in this particular case is you've got a set of accounts, so you have 13579 and 24680, and etc. And those accounts are processing against a table, and then the result of that is an updated table with additional data in it. I will tell you that if you get bored and you want to go look at things, 95136 and 94578, those are zip codes in California, and they're places that are of interest to me, I should say. So as an example, 95223, that's the zip code where I'm sitting right now. So you can Google 95223 and you can see the zip code where I am in beautiful Arnold, California. So the key thing here is that the value 24680 is specified twice. So it's got 1500 and 2500, and the original table's got 2000 in it, and then the result of 24680 is 6000. And that was one of the nice features about the original merge, was that you could think about processing something like a ledger where, you know, Chris went in and he got $2,000 out, and then later on he came out and got, you know, another 1,500 or 2,500 out of the ATM. And as you're going and reconciling, you know, it just naturally flows and allows you to have multiple values for the same account number. The new enhanced merge does not allow that, and that's an SQL standards thing. So as you look at the enhanced merge with full select, these are just two different tables. It looks very similar. The difference is that instead of using an array variable, we're using a table as the input, and a table as the output, also the target. And you can see that in this particular case, I didn't add multiple rows for 24680. So the extended merge has a lot of capability in it. The first thing you can think of is that you can have a matched clause, and you can do something like, in this case, I'm doing an update and I'm adding two values together. And you can have multiple match clauses, and in this particular case, I'm also matching on a global variable. So if the global variable is blank, I'm going to add two values together. If I put a value in the global variable and it's replaced, then I'm going to take the targeted value and set it equal to the source value. And if the global variable happens to be delete, I'm going to delete that record. If the global variable happens to be signal state, I'm going to issue some sort of failure message. And if it's not matched, then I'm going to do an insert. And then the final clause that's allowed in the extended merge here is the ignore clause. And the ignore clause basically allows you to say, well, it didn't match and it did not match. I'm just going to leave that record alone, as an example, or leave that value alone. I'm not going to process it. So the new capability is quite interesting. If you go out and look at iDoug and you Google Meg Burnell and myself, Chris Krohn, you'll find a nice article on that. And then there's a reference to an article from a customer who did a very nice, I'll call it white paper. It's more than an article on merge and the capabilities. And like I said, it's quite comprehensive. So, and on to the next page. So some other things that DB212 had the median and the %cont and %disk functions. DB210 had these, but they were only for IDAA offload. So if you had IDAA, you could use them in DB210 and 11. But in version 12, they're native functions. They can be used as part of the SQL against base tables in DB2. Median is just what it sounds like. %cont and %disk are very similar to median, especially if you specify 0.5 as the input, because you can see %cont and median are the same value here against the salary table. %disk is basically has to be a value that is in the input data set. So the median value for salary is 49,545, but nobody in the group actually makes 49,545. but somebody in the group makes 49,250. And so that's what the median disk is. It has to be a value that is the in the input data set. So hopefully that's straightforward. All right, some other built-in functions that are interesting in DB2 version 12, generate unique binary. So there's a generate unique function already in DB2. It returns a 13-byte value, which is compatible with LUW. Under the covers, it's using a hardware instruction called store clock extended, STCKE. And that instruction returns a 16-byte value, which includes a store clock value, a time value, and it includes a CPU ID and a data sharing member number. So because of that, it's guaranteed unique across a sysplex. So you can generate these things and it doesn't stall the processor. It's going to give you a guaranteed unique value. It is not guaranteed to be ascending because you could be getting processor 1 and processor 4 as an example, giving the same exact value back at the same time. But one of them's got this special value that says this one came from processor 4, another one's got a value that says it came from processor 1. The original generate unique basically trimmed some values out of that 16-byte value so that we could get down to 13 bytes for compatibility with LUW. But one of the things that had to be done was we had to limit the number of processors to 256 processors. And as you might have noticed with the Z15, there's 190 processors in the box. So the thought is that we needed to support the full generate unique 16-byte value to support beyond 256 processors. Also added to this is the varchar bit format, which is also an existing function, but now it'll take the 16-byte store clock value and return a timestamp. So again, you can use generate unique. It's a guaranteed unique value across the sysplex. Again, not ascending, not guaranteed to be ascending because of the other things, but you can get a timestamp value out of it. So if you're looking for something that's really cheap to execute for a unique value, this is actually a pretty cheap instruction. Some hash functions. These are really intended to do hashing against character string data. As an example, maybe you insert a lob value and you hash it. And then later on, if you want to do a comparison to see whether the two values are equal, rather than comparing the large lob value, you just compared the two hash values. So those are pretty interesting. And again, very efficient because under the covers, they're executing hardware instructions. Okay. So array enhancements. We talked about arrays in version 11, and the limitations were really no global variable arrays and arrays of lobs were missing. And so now in version 12, you get global variable arrays and arrays of lobs. So that's something that's really nice. And then the array ag function can now be used on associative arrays. And for compatibility with LUW, there's an optional order by clause. So now arrays can basically be used anywhere. They can be used in COBOL applications. They can be used, in Spoofy. They can be used anywhere where you might want to squirrel away some values and build a lightweight result set. So these are kind of lighter weight than say a declared or created global temp table because they're always going to be in memory. So in this case here, I've got the product table with some values in it. I'm going to stick some data in it. I've got snow shovels and ice scrapers, and then I want to remove a value. So I'm going to use the array delete function to get rid of the ice scraper. So now I've just got an array of snow shovels. And $50 for a snow shovel is pretty pricey, I think. But hey. All right, SQLPL. So the big change in SQLPL is what's called advanced triggers. At least in my opinion. I remember back in the version 6 days doing triggers, and my one complaint about them is that you couldn't have any real logic in them. If you wanted to do anything useful inside of a trigger, you had to call a store procedure. So again, how do I know which one I'm using? If I use mode db2 SQL, I'm using a basic trigger. If I don't specify that, I'm using what's called an advanced trigger. And advanced triggers are basically the full SQL PL repertoire. So, you know, you can issue something like create or replace trigger. So that's something that's new in Db2 12, the ability to use the or replace clause on this, which again is a nice usability function for people who are writing stuff, because you don't have to delete something and then, you know, check to see whether the delete worked or not. You can simply just say create or replace, and if it's there, it gets replaced. Some other capability that was added for any type of SQL PL capability is the ability to have constants. So that's whether it's procedures, functions, or triggers, you can have constants now. If you're familiar with triggers, you might be aware that triggers have order associated with them. So if in this case, I've got trigger 1 and trigger 2, and the way that they get fired is they get fired, trigger 1 gets fired first, and then trigger 2 gets fired. So in this particular case, I'm going to do 3 insert values, and I'm going to use a sequence value. And then in trigger 2, I'm going to multiply that sequence value by 2. So what ends up happening is because trigger 1 fires and gets a sequence value, and then trigger 2 multiplies it by 2, I get 2, 4, 6 instead of 1, 2, 3. So hopefully that's clear. If I was to alter the sequence to restart with 1 again, drop the trigger, recreate the trigger, right? And then do the execution, the same execution, I would get 1, 2, 3, because what's going to happen in this case is trigger 2 is going to fire first, and there's no value there. And then trigger 1 is going to fire, and trigger 1 is going to fire, and it's going to do the next val for sequence, and you're going to get 1, 2, 3 instead of 2, 4, 6. Okay, if I use create or replace, and notice that there's no drop here. The previous page there's a drop. If I use create or replace and no drop, what's going to happen is I'm going to get 2, 4, 6 because I'm going to retain the execution sequence of trigger 1 firing and then trigger 2 firing. So create or replace is one way to do that. There's also other ways. There's versioning, so you can create a trigger with version 1 and version 2, and you can alter activate version 2, and that retains the execution order that it was previous in. So that's pretty nice. So this slide just kind of goes through the same things. You can either use create or replace with versions, you can use alter, trigger and replace, or you can use alter, add, and then activate. So all of those will retain the trigger ordering. And again, that was something that customers really liked, because if you're using triggers with Db2 tables, they're really an extension of the application, right? There's application logic essentially in that trigger. And so any sort of trigger maintenance is essentially an application outage prior to version 12. But now with version 12, you can actually, you know, do something with the trigger and actually, you know, not have to take an application outage, because the changes are immediate. You're retaining the order of execution that you had before, etc. So that's a really nice feature. Okay, so dynamic SQL in SQL PL functions, which came out in version 10, you could never do dynamic SQL in the past. The thought by the developers was, well, who would want to do dynamic SQL in a function? Because every time you execute the function, which could be once per row as an example, you would have to go do something like execute the prepare. But you know, they weren't considering somebody like SAP, which only manages dynamic SQL. That for SAP to have static SQL in a function is actually a little bit awkward for them, because they don't know how to manage static SQL. So in fact, this was added for SAP. They wanted that capability. SQL obfuscation. So if you think about Db2, you know, when you install it, I think there's like 150 procedures and functions that are created, something like 11. It's either 7 or 11 WLM environments that are needed to execute all those things. One of the thoughts would be that it would be nice if Db2 could have SQL PL to replace some of those things. You'd get a zip offload potentially. You know, it would be useful to execute those things that are kind of lightweight and didn't require a lot of logic. The problem is that customers could modify them, right? Because they're just logic today that you would execute a create or replace as an example. You could see what they are, and a customer could maybe go in and modify it, and then you have Db2 depending on a store procedure that's been modified by a customer. So this obfuscation capability allows Db2 to hide the logic inside there, and what you actually see here is obfuscated text with this wrap function. It creates this obfuscated text, and the customer can't see what's inside there. Again, you could potentially go in and replace it, but you wouldn't know what you were replacing, so that would be a little bit different. So the wrap function basically can be used with create function, procedure, or trigger, and what it does is it builds obfuscated text. I use the word obfuscated because it's actually just obfuscated. It's not encrypted or anything. If you really wanted to figure out how to reverse engineer it, you could. The other thing that I would say is that the SQL statements, just like for a normal COBOL store procedure or something like that, they're not obfuscated. So if you go look in syspack statement, you can see in this case, the function or the trigger executes the set nt1.c1 equals c1 times 2. Under the covers, that's rewritten as a update statement, and it's obviously visible in syspack statement. So it's not complete obfuscation. All right, on to the function level. So M501 was the first function level, and it has just one function in it, which is the listag function. It was Db2's test function level, if you will. So listag was something that a bunch of customers asked for, and in this particular case, we're going to run against the work department table or the employee table, and we're going to figure out what the position of the employees are. So department A00's got a couple of clerks, the president, and a couple sales reps. Don't ask me why the president has clerks and sales reps working for them, but I didn't create the table. So that's regular listag. If you noticed, I did the R trim and a comma here because I just wanted to make it look nice. Otherwise, it's kind of doesn't present very nicely. Or you can do a distinct, and in this particular case, it gets rid of the multiple clerks, right? So I just have one clerk, one president, one sales rep, and A00. So nice little function that gets you some data. All right. Another thing that SAP asked for was some Unicode capability that was missed in version 8, which is the ability to cast a numeric to UTF-16. So in this example here, salary plus bonus plus commission is numerics, and when you're executing the graphic function on it, it's actually going to create a UTF-16 value there. And I will say that Christine Haas, again, back in the day, $157,000, so that's making pretty good money. So there was a change to temporal auditing. It's really difficult to explain exactly what it is, but I'm going to try here. So in version 11, there was an enhancement done for temporal auditing. And it was done after the release was built. And so you could create some columns that would indicate what had happened. So in other words, you could add a column that Db2 would maintain that says, well, who did what? So in this case, I did an insert statement, and there would be an I as an example to say it was an insert, and the user ID would be Chris because Chris did the insert. And those are columns that are created by Db2. It's called temporal auditing. Well, if you already had a temporary table and you added columns to it, a temporal table, you ended up with null values for those existing rows that were in that table. And the way that the SQL was processed, because under the covers, Optimizer is doing a query rewrite to get you the data. Optimizer, the way the query rewrite was written is it basically excluded those original tables or the original rows. And the customers who are using this all said, well, we don't like that behavior. The problem is, it's, you know, they didn't like it 3 years or 4 years after it was shipped, not 2 days after it was shipped. And so the change here is to have the query rewrite change in such a way that that those records show up now in the queries, but it's an incompatible change if you have this capability. So it was introduced at a function level. And I'm sorry if that was confusing, but I guess the only other way would be to have some very, very complex queries to show you, but hopefully that's understandable. Okay, M504 had a bunch of IDAA built-in functions added as pass-through. So if you have an IDAA version 7 IDAA, so this is the LUW blue-based IDAA, not the not the Netezza-based IDAA. So things like percent rank, percent entile, lead lag, those sorts of things are now available. The ones that I think are very interesting are the regular expression functions. So these are actually, think of them as very powerful like expressions. And so those are nice to have access to. There was also some new syntax alternatives. So this is for compatibility with LUW and some other platforms. So things like, instead of saying is null, you can say is null with no space. So those are just, we call them, or we tended to call them in the Db2 development team, syntactic sugar. They're basically, the parser swallows these things and the rest of the product doesn't see any difference. Encrypt and decrypt. So there's some encrypt and decrypt functions that have been around for a long time that use DES, and they were never enhanced to use AES because key management was a big problem with them. You basically had to provide a key as part of the execution, and really nobody really wants to provide a key because it's in the clear, etc. Well, with the capabilities that have been added in Z14 and encryption of pretty much everything, right? Encrypted data sets and everything. There's also capability for key management that wasn't there in the past. And so in this example here, I got a table and I've got a phone number, and I want to encrypt it because that's PII data. So Chris is going to encrypt the phone number. If you're not familiar with 8675309, that's Tommy Two Tone's song, Jenny Jenny. You can Google that number. The 408 is the area code for San Jose. But I will say it's kind of funny because there's this blog in here, the News from the Lab blog, that you can go look at. And I wrote that and gave the information to one of the tech writers in DB2, and she changed it to 555 because 555 is a code that's not used in the United States. She didn't realize that she was getting rid of 8675309, which is like I said, a very famous song. I thought it was kind of funny. Anyway, so the interesting thing about this is that you can provide a key label. So my key label is a key label, and I'm using AES here to encrypt it. And then I can decrypt it, and I don't provide a key label because the key label is actually part of the data. So you can actually have a different key label used on every record of data, as an example. And maybe my key label is only accessible to me, and your key label is only accessible to you. And if you tried to fetch my record, you wouldn't have access to my key label, and therefore you wouldn't see the data. So it's kind of interesting that you can do that. So like I said, literally on every record, you could use a different key label. All right, almost finished here. A couple of other things that were added in 506, a bunch of syntax alternatives. So char length for character length, covar pop for covariance, hash for the hash functions that I showed you earlier. For this is compatibility with LUW's hash, so that the way that their syntax is, and then power for POW for power, random, etc. So again, some family compatibility items that help with portability. All right, I think this is the last slide. Numlock US and numlock TS. You might be aware of those. Those are the numbers of locks a user can have total and the number of locks on a table space. And those are ZParms. But customers have asked to be able to set those on an individual user basis. And so what Db2 has done is they've given the capability to have global variables for these values. And then you can set those values to some specific value to let a specific user, as an example, have more locks, as an example, before lock escalation takes place. And they were done as global variables because, again, you can have authorization. So, you don't necessarily want to let everybody have as many locks as they want. That could be a bad thing, but you might have an application that you want to allow to have more locks than most other applications. So you can control that using the grant and revoke capability that global variables have. One more here. So in M507, some additional pass-through built-in functions for IDAA. So, and 507, the other one that's interesting, create or replace for procedures. So version 12 base has create or replace for triggers. Now 507 has the ability to do create or replace for procedures, which really helps with some of the maintenance activities with procedures. If you had procedure 1 call procedure 2, in the past you couldn't drop procedure 1 and recreate it without dropping procedure 2 first. And now with create or replace, you can actually use the create or replace function to essentially replace procedure 1 and not have to deal with that dependency nightmare. So that's a nice capability that was added. And with that, we are finished. So I think that if you wanted to summarize, you can see that a big focus has been on family compatibility for SQL and SQL PL. There's been some increased support for OLAP and analytical SQL, things like median built in, but also some improved capability to do pass through to IDAA. And then there's been quite a bit of focus on SQL PL, rounding out capability in SQL PL. And with that, if there are any questions, we'd be happy to take those now. I'm kind of got about 5 minutes left, I think.
Okay, what I'll do is I'll unmute everybody. So far away. Come on, ladies and gentlemen. You got some questions?
Is anybody there?
Oh, you've got loads of people, Chris. You've got 33 people.
Oh, that's nice.
Oh. Hi, Chris. Marcus Davidge here. The XML box has been ticked after it was popular, and now Json is the flavor of the month. Do you know if IBM or Db2 will have any support for Json coming soon? I noticed the arrays is the use of arrays is a very good step towards that.
Yeah, so there is some JSON capability in Db2. You may not be aware of it, but there is the capability to store JSON, right? It's basically stored as BSON, so binary JSON, and you can use an index on the data, so you can index the data. But that was kind of where it stopped. There are some what's called JSON publishing functions that LUW has that I know that the team was looking at. And you kind of alluded to it here. The way that those functions are built in LUW is they're actually using the listag function. So these JSON publishing functions actually use listag, and it's a query rewrite done by the optimizer. And so I know that the team was looking at doing that, essentially that same work for these JSON publishing functions.
Okay, great, thanks.
Any other questions?
I was going to say that it's actually kind of getting hot here this morning, so I'm going to take my jacket off. You gotta enjoy it. It's supposed to snow on Friday, so.
Oh right, you might make the best of it while you can.
Yeah.
And in the UK, Karen's just said we've turned the heating up. That's the other side. There you go.
All right. Well, thank you guys. I wish I was there to have a pint with you. I think we were supposed to be in Wales or something, weren't we, this year?
Yep, near Marcus, I believe.
Chris,
Yeah.
just very quickly, an observation. A couple of slides after I'd asked you about performance, you mentioned about the optimize for n rows quirks of pagination. So yeah. I have actually already been in touch with the developers, and I'm hoping that that is their issue.
Okay, that's good. So hopefully we solved your problem.
Wow. We've solved one person's problem. That's really good. That's excellent. Yeah. So 3 things really. Thanks very much indeed, Chris. Great presentation. Really good stuff in there that we can all get to grips with and go away somewhere and play with. So that's great. Secondly, please remember the feedback. There's links to the feedback that we can use. And thirdly, there is a charity that is a charity for the GSE conference this year. It's the NHS Friends charity. Please put some money in there if you feel able to, and that would be really beneficial to all the people helping to keep us going in these times. So thanks so much, everyone. Thanks for coming along, and thanks again for Chris for that presentation.
All right, and I hope to see you guys next year.
Yeah, hopefully we'll be somewhere in Wales next year.
Yeah. All right, everyone take care, stay safe, huh?
Thanks, guys. Cheers.